levels. So here, as I said, each trophic level, okay, there will be a flow of energy between these trophic level. That is, from the first consumer, the energy will be flowing to the next consumer. So in an ecosystem, an energy comes from the sunlight. So out of the total solar radiation falling on the earth, only about 1% is being captured by green plants, and it is converted from one form to the other. Only 1% out of the total radiation falling on the earth, only 1% is being taken in, and this energy gets continuously transferred from one trophic level to the other by repeated eating in a food chain. So in a food chain, you will be seeing that it's a repeated eating. One organism is being eaten by the other organism, a repeated eating, and this repeated eating will transfer the energy from the first organism to the second. So there will be a flow of energy. But one thing you have to remember is, when the organisms are being consumed by the higher trophic level, there occurs a loss of energy as heat at each step of energy transfer in the environment. There's a loss of energy. That is, when from here, the first trophic level, it is being consumed by the primary consumers. During this time, there's a loss of energy. The loss of the energy can be in the form of a heat, or you can also say the plants, when they are utilizing the solar radiations, they utilize it for its own mechanical or metabolisms, like the respiration or the digestion. Same way, when the producers are being eaten by the consumers. Okay, so what's happening? One example, if I say a grass is being eaten by a goat, so in that case, you can see the energy which is being stored in the grass is being used for its respiration purpose, for its digestion purpose, for all the metabolic activities which is happening in a goat. You can see the energy which was stored in the grass is being used. So here, when the flow of the energy happens from one trophic to next trophic level, the energy amount decreases. So at each trophic level, organisms utilize energy for different metabolic activities. So on an average, about 10% of available energy actually gets transferred from one trophic level to the other in the food chain. Okay, so here, if 100% of energy which was utilized by the plants, out of that 100%, only 10% of the energy will be transferred to the next level, and 90% will be utilized for its own purpose. So here, see, one example is given. Suppose the solar energy is being taken in by the producers. The producers in the energy, they get 1000 kilojoule. Okay, now here 1000 kilojoule is the energy which a producer got it from the solar radiation. But out of this 1000 kilojoules, 900 kilojoules the producers will be utilizing it for its own metabolic processes, and some of it will be lost as heat. And out of this 1000 kilojoule, only 10% will be transferred to the next level. So out of 1000, the 10% means 100 kilojoule. So only 100 kilojoule is being transferred to the next trophic level. Out of the 100 kilojoule, 90 kilojoule will be used by the primary consumer for its own metabolic processes, and only 10% of 100 is 10 kilojoule will be transferred to the next trophic level. Out of 10 kilojoule, 9 will be used by the consumers, and only 1 will be transferred to the last consumers. Okay, so here you can see this limits the step to maximum of 4 or 5 in a food chain. So because of this loss of energy, while the energy is being transferred, because of the loss of the energy, the trophic levels maximum 4 or 5, because beyond that there will be no energy to be transferred. Because the energy transfer, you can see only 10%, on an average only 10% of energy is actually transferred to the next trophic level. So you call this as a 10% law. The energy available at each successive trophic level is 10% of the previous level. So here you can see, and here 100 kilojoule is 10% of 1000 kilojoule. So of the previous level, only 10% is being utilized by the next trophic level. So only 10% of the energy is being transferred to the next trophic level, while 90% of the energy is being used by the present trophic level in its life processes. Okay, so this you call it as a 10% law. That is, only 10% of the energy will be transferred to the next trophic level. Here you can see one more example. Suppose from the sunlight, there's 1 lakh joule of sunlight. Okay, now out of the total sunlight, only 1% will be used by the producers. Remember this, out of the solar radiations falling, only 1%. So here you can see only 1% energy transfer to the producers. So 1% of 1 lakh is 10,000 joules. Sorry, not 1 lakh, 10 lakhs. Okay, suppose there is a 10 lakh joule of sunlight, only 1%, that is 10,000. So here when 10,000 joules is being used by the producer, they are being consumed by the producers. Out of that, 90% will be used for its metabolic processes. So only 10% will be transferred to the next level. So here you can see 9,000 will be used for its own purpose and 1,000 will be transferred to the next trophic level. Here out of this, 900 will be utilized for its own purpose and 10%, that is 100 joule, will be transferred to the next trophic level. Here 90 joule they will utilize it, and 10% of 100, that is only 10 joules, will be transferred to the next trophic level. So the flow of energy do happen from one trophic level to next trophic level, but at the same time the quantum of energy gets on decreasing. Okay, the amount of energy keeps on decreasing when it's being transferred from one trophic level to next trophic level. So this will limit the number of trophic, maximum 4 or 5, not beyond a 5 trophic level you will not find any food chain. So what are the characteristics of this food chain? We'll study the characteristics. First of the characteristic is there's a unidirectional flow of energy from producers to consumers. It's unidirectional. It will be always from producers to primary consumers to secondary consumers. It will be never reverse. Unidirectional. That's the first characteristic. The next characteristic is there are generally 3 to 4 trophic or maximum 5 trophic level, not more than that. It's always straight, as you said. See, it's always straight from producers to consumers. Okay. Organism can occupy different trophic levels in different food chain. So here you can see if a grasshopper, okay, or you can say I'll take this example. Okay, here you can see a rat here forms the secondary consumer, but at the same time in some other food chain a rat can be a primary consumer or it can be a tertiary consumer. So different organisms, they occupy different levels in different food chain. Here cat you can see as a secondary consumer, but at the same time a rat, at the same time a rat can occupy the position of primary consumer in another food chain, or maybe a position of a tertiary consumer in another food chain. So different organisms, they have got different trophic levels in different food chain. There is a gradual decrease in the amount of energy from one trophic level to next trophic level. So as we already saw, decrease of energy from one trophic level to the next trophic level. So these are the different characteristics of the food chain.